All right, let's get started. Hi, everyone. Welcome to today's technical workshop. We're gonna talk about Dragonfly with Kubernetes, right? And yeah, so basically we're gonna answer the question how to scale the in-memory workloads to millions of operations per second with Dragonfly using its newly released Kubernetes operator. Cool, so let's get started. We have a TLDR. If you're in a rush, you don't have to go through the whole session, but basically just do nothing, right? Just follow the documentation we have, and without any optimization or anything, choose the right machine size for your workload, and follow the documentation. You will be able to reach millions of QPS per second. Yeah, that's basically it. And after this, we're gonna dive in. We're gonna talk about a few things today. For those who aren't familiar with Dragonfly, we're gonna do a brief introduction, and then we're gonna take a look at the Kubernetes operator pattern. To be honest, before I'm working with Dragonfly as a developer advocate, I was a developer. I'm personally not that familiar with Kubernetes, so it's a great learning journey for myself as well, right? And then we're gonna take a look at the newly released Dragonfly operator features, what we have, what we can offer, right? And then we're gonna do a small live demo, and yeah, just to show off some of the features that we have for the operator. And finally, because now we have all the tools, right? You have the Dragonfly core, you also have the Dragonfly operator, right? So why are we still building Dragonfly Cloud as an offering for you? So we're going to cover these topics in this workshop. Nice. So first off, for new community members and for those who are not familiar, Dragonfly is an open source project, right? Currently, we have 21.6 kilo stars, which is very nice. Thank you all, community members, for supporting us. Right? And Dragonfly is an in-memory data store, and on a single AWS C6GN 16x large instance, we were able to achieve 4 million operations per second. And it's also, it is also able to operate with 1 TB in-memory data. API-wise, Dragonfly is 100% compatible with Redis and Memcached in terms of the wire protocol and everything, right? Command-wise, we're still catching up. Currently, we have more than 220 Redis commands implemented, and those are the most used ones, right? So yeah, and transition should be like very smooth if you ever decide to try Dragonfly or do the migration. Dragonfly is also very hardware efficient. We can, based on our tests, it can save you up to 50% in terms of hardware costs. Right? We also offer a primary replica model for high availability, and we have a very active community on GitHub and Discord. So yeah, you're very welcome, to join whatever way you want. Looking at issues, questions in Discord, GitHub. Yeah, it's always welcome because Dragonfly it is a community-driven project. Nice. Next, we take a look at the Kubernetes operator pattern, right? So Kubernetes by itself, at its core, it is designed to have this control loop mechanism, right? And it is very excellent for managing stateless applications. When I was doing more development work, I wrote a lot of web applications, like those backend CRUD applications, right? So most of them, they are stateless in terms of like what the pod is running, like they're running my services. We have some like in-memory states, but most of them like they're request scoped states, right? So they don't have to be persisted because they just the state they're with the life cycle of the requests, right? So and also when I run those pods, they are all identical most of the time. Like for each microservice, no matter how many replicas I have for each of the service, they're identical, right? So they're the same thing, and they're like interchangeable, and they actually don't maintain any long-running internal states. So in a Kubernetes environment, this means that the control loop can seamlessly manage the lifecycle of these stateless applications, right? It can still scale them up or down like very easily, handling like rolling updates, managing their health checks and everything, right? So the control loop basically continuously monitors the current state, the actual state of your cluster, and yeah, it compares that with the desired state, and it will try its best to work to match it with the desired state. So yeah, that's a simplified version of like how Kubernetes works. Yeah, it's amazing technology. But when it comes to the stateful applications like a data store, right? It's not that easy anymore because there are like things we need to take into consideration, like persistent storage and everything. And maybe if you're running a database, the network identities need to be static as well, because otherwise your applications wouldn't be able to, talk to your static address, right? Like if your application cannot find your database, it's going to be um, in a big trouble. That's why data stores and those applications are normally managed using stateful sets in Kubernetes, right? So we have pros for stateful set. As I mentioned, you're going to have like stable network identities. You're going to have stable persistent storage, right? And you can also have like ordered and graceful shutdown, deployment, and scaling strategies. So you're going to have all these benefits while you're using stateful sets. But when it comes to stateful sets, we have like challenges as well because as I mentioned, now you're managing data stores, maybe in memory, maybe like on disk, right? It naturally requires more careful planning for your persistency, for backups, for recovery, and everything, right? And also, every and each application, like they're different because for different data stores, maybe they have their own features and stuff, and you need to manage them like differently, right? So that's why there's no like all-in-one solution like what we have here for stateless applications, right? There's no all-in-one. So for each application, you're going to have to develop what is called a Kubernetes operator to help you do the management, right? Yeah. So the operator, it basically extends the Kubernetes capability to automate the management of stateful applications, in our case, to manage Dragonfly. Nice. And then, as you may know, if you're following the community, the Dragonfly Kubernetes operator, it reached 1.0 or GA last Monday, November 6th. So it's last Monday. And the operator makes it much easier to manage Dragonfly instance for you as a developer or for your DevOps teams. And along with the Dragonfly operator, we have many exciting features, including like automatic failover. We can do scaling either horizontally, because Kubernetes can control resources as well, right? Or vertically. Also, the operator supports a lot of customizable configuration options, right? And also on the security side, we also have like authentication and server client mutual TLS. Yeah, and it's very important. If security is always important. Most of the time, we worry about this probably later, but it's definitely important to keep in mind. On the snapshot side, we support snapshots to PVCs or directly to S3 compatible cloud storage. So yeah, those are great ways to keep your snapshot backup files, safe and highly available if using cloud storage, right? And cool. And finally, on the monitoring side of things, we have support for Prometheus and Grafana, right? So yeah, as I mentioned earlier, it's very nice because we have our updated pages for documentations as well. It's very comprehensive, and yeah, we have like different sections for each of the features that we mentioned earlier. So if you're managing Dragonfly using the operator, this is the place to go. Nice. So yeah, there are like many features, and we won't cover all of them, but we will show like some examples, right? For instance, we have high availability, failover, and scalability, right? So the operator itself, it's kind of acting as, as its name implies, it's like a human operator, but it's just coded, right? So it is able to, monitor if you have like a multi-replica setup of Dragonfly, right? The operator is going to be able to monitor the status of these instances of pods that are running, right? So let's say if the primary dies, the operator is kind of like Sentinel. It is able to detect that and then do a failover to one of the replicas, right? Although, because we're talking about like, very high demanding in-memory data store as Dragonfly, so I don't think this guarantees like there's no data loss at all, right? Because it's just a high availability doesn't mean like completely consistent across, across like a huge cluster if the primary goes down, right? But in terms of availability, it is going to be online. So when the switchover happens, maybe the data loss could happen, right? But it's still available. If you're using like Dragonfly as a caching system, I think to a certain extent, maybe the data loss can be tolerated, right? So we have HAN failover. Similarly for scalability, right? Because Kubernetes can control your hardware resources, right? So we're going to show a demo very soon. If you like increase the resource of your pods, right? The operator is able to handle that and it will do that very smoothly. So that's for vertical because you're currently demanding each pod to use more resources, right? For horizontal, similarly as well, if you want to add more pods, yeah, that's quite common and that's totally doable with the operator. And we're going to do a demo very soon to show this. Next, we have like custom configuration options as well. I have a link here, and it's also part of our documentation under managing Dragonfly, Dragonfly Operator, right? So this link is also part of the section over here. As you can see in this table, we have many configuration fields arguments that we can use, right? For instance, this args field, you can basically pass like any Dragonfly server configurations that you want. Maybe you want to run it using an emulated cluster mode and stuff like that, right? And another good example would be we can also directly specify, the snapshot cron schedule. So if you set it here, it's on the Kubernetes level, right? Like the pod level, not the Dragonfly server level, right? So you can do like fancy things over here, doing TOS, doing like authentication and stuff. So it's a great example of how customizable this is for you. Cool. Now we're gonna it's demo time. We're gonna do like a short demo to show how easy it is to deploy and manage Dragonfly using the operator, right? So I will deploy a Dragonfly primary replica setup, and we're gonna update the configuration to scale up, down, and we're also gonna see like how it snapshots to S3 directly, right? So again, like we didn't do anything, we haven't optimized anything, but we just follow the documentation, and our recent benchmark shows that we were able to achieve 1.3 million ops per second on this instance running in Kubernetes, right? Because the number is lower because first off, this is a smaller machine that we tested, and secondly, like even nowadays, all those containerized platforms, like they're so good, they're so fast, right? It's kind of like running application directly on Linux, right? But we still have like a little bit of overhead, and because Dragonfly, it is a in-memory store and it's very sensitive to those little things, right? That's why this number is a little bit lower than if we run it directly on bare metal, but still it's a million level operations per second performance you can get in Kubernetes, right? And on our YouTube channel, we also have like 5 videos that is it's a playlist, and basically there are good demos with our new Dragonfly Operator features as well. Nice. So yeah, so I will not be demoing the benchmark section live today because yeah, it's a little bit hard to set up. Plus, I still have that 1 hour time difference flying back from Chicago from the KubeCon. So we're not gonna do the live demo for benchmarks today, but we're gonna see other interesting things. And the benchmark demo, as I mentioned, it's available in this playlist. Cool. So let's do the demo right now. So yeah, basically what we can do, or what I did for myself when I was running this is, as I mentioned, I follow the documentation pages, right? For instance, if I want to configure Dragonfly to take snapshots to S3 directly with the operator, this is basically where I go, and it is what I can follow, right? So yeah, let's briefly go through this. So what we definitely need an Kubernetes cluster, right? So we can use this command, or you can use the UI to create an EKS cluster on AWS for yourself. So I have already done that. So as you can see, this is my Dragonfly cluster. So once your cluster is ready, you need to install the operator, Dragonfly operator, into that cluster, right? So because it's the operator, it is custom resource definition, it's a CRD. So it's something that the Dragonfly team built to extend the functionality of Kubernetes, right? So that needs to be installed as well. So I believe I have done that, but yeah, just in case we're gonna do this again when I run through the commands. Then we're gonna have to do like OIDC. I've done it as well. It's like all these steps, they're just the idea behind these steps is to configure your Kubernetes cluster with the Dragonfly operator so that they were able to talk to your S3 bucket, right? So I've prepared this, so I'm not gonna run these commands one by one, but basically this is what would happen if you follow along, right? And similarly for the S3 bucket, I have created that as well. Let's check if I have anything. I do have, but let's delete these old snapshot files for demonstration purposes. Cool. So now I think my bucket should be empty right now, right? Nice. And then we're gonna create policy, and I'm gonna create a role for the, based on the policy. And finally, we're gonna have a service account based on the role, right? So all these steps, they are just here to configure so that your Kubernetes cluster is able to talk to your S3 bucket with proper authentication. Nice. So I'm using this UI, this Lens UI, to connect to my cluster, and as you can see, currently I have nothing. Let's see. On my default namespace, I don't have any pod, right? So now what I'm going to do is I'm going to double check that my Dragonfly operator is installed, right? So I can grab this command, and yeah, it's also available here, right? So I'm going to just do this command, and yeah, like it is installed, so many of the resources are not changed. So now I have a clean EKS cluster that also has the Dragonfly operator installed, right? Next, what I'm going to do is I'm going to use the operator to initialize a Dragonfly instance, right? So I'm going to grab my command over here as well. And before I run that, we can take a look, right? So it's basically, using the Dragonfly operator, I'm giving it a name as Dragonfly instances. Currently, it's one replica, right? And I am using the service account that I created beforehand, as mentioned in here, so that the cluster, it is authenticated to talk to S3. And I'm also using the snapshot DIR spec to specify that, I want my Dragonfly instances to take snapshots to this S3 bucket, which is the one we created over here, and it's empty, right? Cool, so let's do that and see what will happen. Right, as you can see here in the UI, it's very nice. We have our stateful set created as well, and we have like a pod running over here. Let's just give it some time so that the pod, the container is 100% ready. Right, so yeah, we have like one instance running, which because we specified only one replica, and it's also the primary, right? And we can just double check, it's one instance, so this pod has to be the master as well, right? Cool, that's very nice. So next, what I'm going to do is I'm going to use this command, which will create a temporary instance running Redis CLI, so that I can use this instance to talk to this Redis CLI client to talk to the Dragonfly instance. This will take a bit, so let's just give it some time. Okay, there we go. So we have this temporary Redis CLI client instance running, and it's talking to our Dragonfly server instance. Both of them, they're running within the Kubernetes cluster, right? So let's see, we don't have any data, right? So I can set some, let's say key one val 1, and also let's do a key2 value 2, right? So now, yeah, so now this Dragonfly instance has like 2 key value pairs in there, right? So yeah, that's it for the COI. So I'm gonna remove the COI, and you can see the COI is gone. Right? So now what happens is let's try something, right? What if I just delete this pod, right? When I delete this pod, so what happened is that Dragonfly, because we have like graceful shutdown handling, so upon exit, Dragonfly will try its best, like try the best effort to create a snapshot before everything goes away. Right? So that's how Dragonfly server works. And because we configured the snapshot location to be this S3 bucket, right? So the snapshot should go here, just right away go here, right? And then because the whole thing is running in the Kubernetes environment, and we have our Dragonfly operator managing this, right? So the operator sees that, oh, your instance just it's just gone, and you specified 1 replica, so I'm going to create one to replace what you have over here, right? And then upon initialization, upon the new pod initialization, Dragonfly will try to read the snapshot files, and in order to restore the data, right? That makes sense, right? And because again we configured the snapshot location to be the S3 bucket, so the new pod will try to read and restore from there as well. Which means that if I kill this pod after this whole process, I should still see this data in here, right? So let's try that. Delete, okay, remove. So it's removed, and I think, yeah, and Kubernetes or the Dragonfly operator, it replaced this pod with a new one, and now it's ready again, right? So let's double check over here, refresh. We do have the snapshot files, right? So yeah, the Dragonfly creates multiple snapshot files. But yeah, this is basically the snapshot we just have, and the timestamp is also correct in terms of UTC, I think, right? And over here, let's try the Ready COI temporary instance again. And if I run that and give you some time, again, this temporary Ready CLI instance is talking to you the Dragonfly server instance. And remember, this instance is a new one. It's being deleted and replaced by the Kubernetes operator, by the Dragonfly operator, right? Let's give it some time. There we go. And if we do the keys again, right, you can see that it's a proof that this new pod has been replaced, and upon initialization, it read the snapshot files from S3. That's why we still have everything over here. Cool. That's nice. So let's turn off the COI instance again. So currently we have like 1 instance running, right? And we can just do a description here, just to remind what configuration, what spec we have. So what we have over here is 1 replica, and we used this service account and this S3 URL to do our snapshot. Right? So what I'm going to do right now is to patch these replicas. So maybe let's try 5 and see how it goes. Right? So this command, we will patch this configuration, and we're going to just replace the spec replica to 5. And let's give it a shot. So now it's patched, and you can see that the operator starts to do its work. It tries to create replicas for our primary instance. Right? So if we give it some time, I think, yeah, it has its own like strategy for readiness check and stuff. But eventually, we should get 1 primary and 4 replicas. Yes, because this replica configuration under the spec, the number is the total number, including the primary and replica, right? So if we do 5, it's actually 1 primary with 4 replicas. So yeah, let's give it some time. And yeah, it's very magical to see the power of Kubernetes plus the operator, because if you don't build the operator, you won't, do the specific things for Dragonfly, right? But on Kubernetes, on such a great platform, on top of that, we build the operator. That's why we have capabilities like this, right? So yeah, we almost have our 5 instances, and let's just double check that for pods, we have like 1 master, which is instance 0, And for replica, we have 4 instances, which are 1, 2, 3, 4, 5. Right? So yeah, now we have like a 1 primary and 4 replica high availability setup for this Dragonfly instance. And if you have like very heavy read workloads, this could be a good setup, right? Next, we try to reduce it down to 3, right? So we're going to use the same command to patch our configuration, but this time around, we're going to do 3. So the operator should just terminate 2 of them, right? So again, if we check master, instance 0 is still the master, and the rest of the 2 instances, 1, 2, they are the replica. Cool. So we just so let's recap a little bit what we had. Originally, we have like a configuration that is 1 replica, and it's able to do snapshots to F3, and or both read and write. So upon shutdown, it will do the snapshot, and upon initialization, it will try to restore using the snapshot files in F3. We also did horizontal scaling, right, in terms of read replicas, right? Imagine you have like multiple machines and you have like very heavy read workloads. Yeah, this is how like you can scale them horizontally. Now let's try something else. We're gonna keep this 3 replica setup, right? But what I'm gonna do is I'm gonna change the hardware resource requirement for each pod, right? So maybe your server is like large, you're not using all of them. Maybe it's small and your workload is small, you want to reduce them. So we're not changing like how many replicas or instance we're managing. We're changing the hardware resource requirement, right? So what I can do is that I'm going to grab this command over here. As you can see, this terminal is a little bit messed up, so do a new one. As you can see here, we are patching the spec with resources, and I'm just like putting some like random value over here for both CPU and for memory, right? So what should happen, right? Let's I'm not gonna mess up with my keyboard this time around. So what's gonna happen like in this topology, right? So if we use the default Kubernetes control loop, right, then it's totally up to Kubernetes. Kubernetes can kill and replace your pods, using any arbitrary order that is by default. But for Dragonfly and in-memory data store, we don't want to do that, right? We probably don't want to kill your primary instance first because the primary instance is where it accepts both read and write. So if this instance is killed first, then your application wouldn't be able to write to any instances, right? So ideally, what should happen is that maybe we replace one of the replicas first, right? And because we only have 3 pods or 3 instances, so maybe we should wait for that replica instance to be replaced and totally ready and also matches the hardware requirement over here. We probably should wait until that, and then we do the other replica, right? And then both replicas are ready, and they're kind of at a newer version. And finally, we do the primary, right? And in the meantime, one of the replicas needs to be promoted as primary as well, because your service needs to continue to run, and it needs a primary to write to, right? So yeah, so basically the Dragonfly operator handles all that. So let's give it a shot. If I try this command, it will say that the hardware requirement has been patched, and let's just give it some time. Oh yeah, it happens. So the operator kills a replica first, and it will wait until this replica is ready, and then it will do the same thing for the other replica, right? And then before it does the same thing for the primary, we're going to have a failover from like the primary to replica. So one of the replicas will be promoted as the primary, and then finally instance 0 will be replaced as well. But when it comes back, it doesn't necessarily need to be promoted as primary again, right? So yeah, as you can see, 0 just get replaced as well. So after everything is ready, we should still have all the data. I'm not going to check, but that should be the case. And as you can see, currently instance 2 has been promoted as the primary, and the other instances of replica, right? So yeah, basically these magic, they are coded, they are built in to the Dragonfly operator, right? So it's not universal. Maybe if you're running different services, you don't want behaviors like this, but for Dragonfly, we figured that's the desired behavior that we want. That's why the team developed it that way. Right? So yeah, basically that's that's a short demo for the operator. Yeah, I have one slide left. It's basically like yeah, we have everything. You have the Dragonfly core, you have the Kubernetes operator. Why are we still building Dragonfly Cloud? Right? So, as I mentioned earlier, Kubernetes and the containerized information like containerd, or whatever, Docker, they still have like those abstraction layer overhead, right? So what we have right now is that we are able to achieve like 4 million on the 16x large instance if we run Dragonfly directly. And we have like 1.3 million on this 8x large running Kubernetes with the Dragonfly operator, right? Like, unfortunately, I don't have the benchmark results for these two scenarios on the same machine. We haven't tried that yet. And yeah, but this machine is basically like, it has like, double the resource of the 8x, right? So we also shouldn't expect this number to be linear, although, one of the design goals of Dragonfly is try to make this number linear, but, even it's perfectly linear, there's still a gap between like 2.6 and 4, right? So there's definitely that containerization overhead, and Dragonfly is very sensitive to this kind of things, right? So that's why the team is building Dragonfly Cloud. So we want to give you all the conveniences, like all the features that I just showed you with the Dragonfly operator. But on top of that, we want to make sure that the Dragonfly core still runs on bare metal. Right? We want to make sure that's the case. So that kind of implies that maybe we cannot use Kubernetes, like for Dragonfly Cloud. That maybe that's the case. That's what the team is figuring out. So we want to give you all the management conveniences and also achieve the bare metal performance. That's why, feel free to try Dragonfly to manage Dragonfly in your production environment, using whatever way you want, using the operator. But the cloud, we use the same code of Dragonfly core, but we want to build like an even better experience for you, right? That's the starting point. Cool. That's it for today, and I hope you enjoy the demo. And we're going to be taking some questions from the community and see. Some of them I will try my best to answer. Some of them like maybe not, but I will definitely get back to you after I check with the team members, right? So, so one question we have is that if the snapshots are saved in the RDB mode, can they still be sent to S3? That's a good question. So as some of you may know, that Dragonfly is compatible with the RDB file, which is the Redis snapshot format, right? DFS, like we believe that it's even more compact and efficient, but Dragonfly is compatible with RDB. So to this question, I haven't tried, but I believe that's the case. It's just a different mode of saving the snapshots. Right? So I will give it a shot later. So yeah, I believe that's the case. If we configure the S3 service account and the URL, the snapshot should go here. So horizontal scaling is done for reads, and writes we cannot horizontally scale. So yeah, so in the demo, what I showed is a primary multi-replica setup, right? So currently, Dragonfly already support cluster mode. We support the emulated cluster mode if you want to migrate from a Redis cluster to a Dragonfly single node. We also like, I don't think it's like 100% ready, but we have the real cluster mode, on the way as well. And since the cluster mode, like the real cluster mode, I don't think it's 100% finished yet. So the operator maybe doesn't support the cluster mode at the moment right now, right? So yeah, maybe in the future. Currently, what I've shown is mostly like read replica setup, right? So in the future, maybe when we have like the real cluster mode, we can also use operator to do the management as well. For integrations, yes, that's a good question as well. So it's asking about like how Dragonfly integrates with other frameworks and stuff. As I mentioned earlier, Dragonfly is wire compatible with Redis. So, in an ideal world, things should just work like perfectly. But maybe some of the frameworks and integrations, like they use very like commands that are not very frequently used, or some other things, right? So we do have like an integrations page. Currently, we have OMQ, ClickHouse, and Fist. So OMQ is a MQ system. ClickHouse, as many of you may know, is an analytical database, right? It supports Redis as the table engine as well, so this can be replaced by Dragonfly seamlessly. And Feast, similar idea, is a feature store for machine learning. And we are actively testing and integrating with other frameworks as well, like some of the famous one, maybe like Scikit for Ruby. So we are aware of the needs of using frameworks or other stuff on top of Dragonfly. So that's why we keep compatibility in mind. We're actively testing and working with the teams. I guess that's the power of open source, right? Like in different communities, we actually say for BOMQ, we actually worked with the BOMQ team and original author, Manuel, to in order to make all these things happen. So yeah, integration is a huge chunk in the community, and we're definitely paying attention to that. Nice. When will be Dragonfly Cloud GA? Okay, so the question is like, when will be Dragonfly Cloud GA? So yes, that's a good question. Currently, we are onboarding customers to Dragonfly Cloud on a wait list or trial basis. So if you have if you're very interested in Dragonfly and the cloud offering, and you have please fill the form if you have any questions or you just want to give a shot. We will get back to you, right? So, but as I mentioned in the slides that we have challenges as well. We want to build all the convenient features for you, but we also want to squeeze the Dragonfly performance, to achieve the bare metal performance. That's why the team is very diligently working on Dragonfly Cloud. I don't have an exact time, but yeah, sometime I would say maybe early next year. Yeah, we should expect that. You should expect that. If you come to this page again, it will become like a login sign up console, and you can use Dragonfly Cloud directly. Cool. Yeah, that's very nice. So I don't see more incoming questions. So I guess that's it for today. But if you do, please find me, find the team members, find the community members and everybody using our Discord, open issues or whatever your findings, on GitHub. If you have good words to say, we get testimonials from on GitHub as well. If you have great things to say to us, it's definitely very, very welcome. We're gonna probably feature that on our homepage as well. And yeah, I guess that's it. Other than that, that's it for today. And I will see you all very soon again. Thank you.